If alpha and beta are the zeros of the quadratic polynomial, find the value of 1 over alpha plus 1 over beta. So this is a quadratic polynomial, p of y, 5y square minus 7y plus 1. Now we're going to write the coefficients. To write the coefficients, we compare it with a standard quadratic. This is our standard. And on comparison, we see a equal to 5, that's the coefficient of y square, b equal to minus 7, and c equal to 1. The alpha and beta are the roots of the roots are alpha and beta. And we know alpha plus beta equal to minus b by a, and alpha beta equal to c by a. So let's go and find out 1 over alpha plus 1 over beta. 1 over alpha plus 1 over beta. We take the LCM, is alpha beta. So we multiply this by beta and this 2 by beta. Here by alpha and this 2 by alpha. And the numerator you have beta plus alpha. And let's put the values of alpha plus beta is minus b by a. So that is minus of minus 7 by a is 5. Alpha beta is c by a. And c we say is 1, a is 5. So minus of minus is plus 7 by 5, divide by 1 by 5, so 7 by 5 into 5 by 1, which is equal to 7. If alpha and beta are the zeros of the quadratic, find the value of 1 plus alpha plus 1 by beta minus alpha beta. So the quadratic is f of x, which is equal to x square minus x minus 4, and you compare it with the general equation that we have, ax square plus bx plus c. Thus we see a is 1, b minus 1, c minus 4. The next step is alpha plus beta equal to minus b by a, which means alpha plus beta equal to b is minus 1. So it will be minus of minus 1 by a is 1. So alpha plus beta equal to plus 1. Then we have alpha beta. Alpha into beta is c by a. C is minus 4 by a. So that is minus 4. That is alpha into beta. We need to find the value of 1 over alpha plus 1 over beta minus alpha beta. We'll first take up this side here and we find the LCM. The LCM is alpha beta. So this will be into beta, here will be into alpha, So in the numerator we'll get beta plus alpha minus alpha beta. Now we put our values. Alpha plus beta here we see is 1. So the numerator 1 over alpha into beta minus 4. Minus alpha into beta is minus 4. So minus 1 by 4 plus 4. LCM is 4 minus 1 plus 16. It will be 15 by 4. Hope you know why this is 16. Because here it's over 1. So into 4 into 4. The LCM is 4. So this will be 15 over 4 is the answer. If one zero of the quadratic polynomial is negative of the other, find the value of k. So the quadratic polynomial f of x is 4x square minus 8kx minus 9. When we compare it with the standard quadratic, we see that the coefficient of x square, that is a, is 4, coefficient of x, b, is minus 8k, and c is minus 9. That's one part of the sum. Now again we'll write the quadratic. And it is given to us that the root, one is a negative of the other. So for the roots, if one root is alpha, the other one will be minus alpha, because one root is negative of the other. So the sum of roots will be alpha minus alpha, which is minus b by a. And alpha minus alpha is 0. And minus b by a will be minus of minus 8k by 4. So here we have alpha minus alpha, because one root is alpha and beta is minus alpha. One is negative of the other, is minus of minus, that is b by a. So 0 equal to, of course, the a here we write it as 4 because a is 4. So this is 8k over 4. So 0 equal to 2k, k equal to 0 over 2. So 0 equal to k. If the sum of the zeros of the quadratic is equal to the product, find the value of k. So the quadratic is f of t, which is kt square plus 2t plus 3k. When you compare it with the standard at square plus bt plus c, we get a equal to k, b equal to 2, and c equal to 3k. Now the roots are alpha and beta. Which means alpha plus beta equal to minus b by a, and alpha beta equal to c by a. Here there is a special condition. Here they have said the sum of roots is equal to the product of roots. So they say sum of roots equal to product of roots. This condition has been given to us. So sum of roots is alpha plus beta. Product of roots is alpha beta. Now the sum of roots we know is minus b by a, and the product of roots is c by a. Now to put the values, the b is 2. So we have minus 2 by k equal to c by a. C is 3k, and this is now here a is k. Here we just do this again. Our c is 3k and a is k. So we take k common out to get minus 2 equal to 3k. So k equal to minus 2 by 3. Now for the next sum, if alpha beta are the zeros of the quadratic, find the value of alpha square beta plus alpha beta square. So quadratic p of x is equal to 4x square minus 5x minus 1. So when we compare it with ax square plus bx plus c, that's the standard quadratic, a equal to 4, b equal to minus 5, c equal to minus 1. The next step, we write the sum of roots. Alpha plus beta equal to minus b by a. So alpha plus beta, b here is minus 5. So this will be minus of minus 5. This is our b. Over a is 4. So alpha plus beta is 5 by 4. Next is alpha beta. Alpha beta is c by a. So alpha beta, c is minus 1 over 4. Now we need to find the values of alpha square beta plus alpha beta square. Here we take common out alpha beta. What remains inside is alpha plus beta. Now let's put the values. Now we saw alpha beta. First we're going to substitute for alpha beta. Alpha beta is minus 1 by 4. So this will be minus 1 by 4. Now alpha plus beta, we're going to substitute for this now, is 5 by 4. So we put here 5 by 4. So we have minus 1 by 4 into 5 by 4, which is minus 5 by 16. For the next, if alpha beta are the zeros of the polynomial, find the value of alpha raised to 4, beta raised to 3 plus alpha cube beta 4. So our polynomial is f of t, which is t square minus 4t plus 3. And now when we compare it with at square plus bt plus c, we see that a, which is coefficient of t square, we call it a, is equal to 1. Then coefficient of t, which we call it as b, is minus 4. And the constant term, which we call as c, is plus 3. Next, we know sum of roots. Alpha plus beta are the roots. Sum of roots is minus b by a, and alpha beta is alpha into beta is c by a. We need to find here the value of alpha 4 beta 3 plus alpha 3 beta 4. Now here in this first term, see there are 4 alphas and 3 betas, and here there are 3 alphas and 4 betas. So what can we take common out? Here we can take 3 alphas and 3 betas common out. What will remain here is 1 alpha, and in this case you'll have 1 beta. This again can be written as raised to 3. So I put alpha beta, because this alpha raised to 3 and beta also raised to 3. So we can put one bracket, common bracket, and write it alpha beta raised to 3. Here we have alpha plus beta. Now we put our values. Alpha beta we know is minus b by a, so that is raised to cube. No, alpha beta is not b by a. Alpha beta is c by a. So this is cube. Alpha plus beta is minus b by a. Now let's go ahead and put the values. We know c is 3. So this is 3. A is 1. So we put 1 cube. Now minus, b is minus 4. So minus of minus 4. And a is 1. So we have 3 cube into 4. 3 cube is 27. 27 into 4, which is equal to 108. If alpha beta are the zeros of the quadratic, find the value of alpha over beta and beta over alpha. Now before we do the sum, we need to learn some formulae. We know alpha plus beta the whole square equal to alpha square plus beta square plus 2 alpha beta. So now if I want to find the value just of alpha square plus beta square, what would that be? Would be alpha plus beta the whole square minus 2 alpha beta. I've just taken this 2 alpha beta on the other side. So this is equal to alpha square plus beta square. This is important. We need to learn this. We're going to use it a lot later. In the same way, we find another one, that is alpha plus beta the whole cube. And alpha plus beta the whole cube is alpha cube plus beta cube plus 3 alpha beta, alpha plus beta. So if I want to find alpha cube plus beta cube, it will be alpha plus beta the whole cube. I will take this on the other side. So it becomes minus 3 alpha beta, alpha plus beta equal to alpha cube plus beta cube. So just to go over it again, here I will do alpha square plus beta square equal to alpha plus beta the whole square minus 2 alpha beta. We need to learn this. And alpha plus beta the whole cube equal to alpha plus beta cube minus 3 alpha beta, alpha plus beta. So in this sum now, the expression given to us is 6x square plus x minus 2. When we compare it with the general equation ax square plus bx plus c, we see that coefficient of x square, which we call a, is 6. Coefficient of x, which we call b, is plus 1. And the constant term c is minus 2. So let me write it again. A is 6, b is plus 1, c is minus 2. And now for the relationship, alpha plus beta is minus b by a, which in this case will be minus 1 by 6. Alpha beta is c by a, and you see the c is minus 2. Minus 2 by 6, which is minus 1 by 3. Now we need to find the value of alpha plus, we need to find alpha over beta plus beta over alpha. So we're going to find the LCM. LCM is alpha beta. Now we will multiply this by alpha and this also by alpha to make it alpha beta. This denominator to make it alpha beta into beta into beta. So what we get up here now is alpha square plus beta square. Now if you recollect the earlier slide, I told you what was alpha square beta square is alpha plus beta the whole square minus 2 alpha beta over alpha beta. Now let's put the values. Now alpha plus beta is minus 1 by 6. So here we'll put minus 1 by 6 the whole square. Alpha beta here is minus 1 by 3. So this is into minus 1 by 3 over alpha beta minus 1 by 3. Let's go ahead and solve this expression. So this is our expression. Now let's go ahead and solve it. So in the first, minus 1 by 6 the whole square will be 1 by 36. Minus minus plus 1 by 3 we have divide by minus 1 by 3. So let's first solve the numerator. In the numerator we will take LCM, and the LCM is 36. It will be 1 plus 12. Denominator minus 1 by 3. Okay, so for this one I think it should be into 2 here, which I have not written, so into 2. So this would be, just do this again. So we'll have 1 by 36 plus 2 by 3, that's a numerator, over your denominator is minus 1 by 3. In the numerator we'll take the LCM, and the LCM is 36. So it will be 1 plus, this will be into 12, so 24. This is the division. The denominator is minus 1 by 3. So now for the numerator again, it will be 25 over 36. Divide by minus 1 by 3. Next step, 25 by 36 divide by minus 1 by 3. So 25 by 36 into 3 by 1. That will be 25 by 12 minus. If alpha and beta are the zeros of the quadratic, find the value. So our quadratic here is P of S, which is equal to 3s square minus 6x plus 4. So next the coefficient of s square. So the coefficient of s square, which we call a, equal to 3. Coefficient of s, which is b, is minus 6, and the constant term c is 4. In the next step, we know alpha plus beta is minus b by a, and in this case minus, our b is minus 6, so minus of minus 6 by a, that is 3. So alpha plus beta is plus 2. In the next we have alpha into beta. Alpha into beta is c by a, and that would be 4 by 3. Now here we need to find the value of a rather long expression, that is alpha beta plus beta alpha plus 2, 1 by alpha, 1 by beta plus 3 alpha beta. I think we take it on the other slide. We have to work this in sections. So first we work this section. Here the LCM will be alpha beta. We multiply this by alpha to make it alpha beta, this again by alpha, this beta, and this also beta to make the LCM alpha beta. So here we have alpha square plus beta square plus 2. Now we work this section up. Here LCM again is alpha beta. So this would be into beta to make the denominator alpha beta into alpha into alpha. So this would be beta plus alpha plus 3 alpha beta. Now if you recollect, we have studied what is alpha square plus beta square. Was alpha plus beta the whole square minus 2 alpha beta. Now this is over alpha beta plus 2. We know alpha plus beta is minus b by a, and we have already found that out earlier. Let's remind ourselves. We know that alpha plus beta, we found it earlier, was 2, and alpha beta was given as 4 by 3. So now let's put the values of alpha plus beta. Earlier we found alpha plus beta was 2, and alpha beta we found was 4 by 3. plus 3. Alpha into beta is 4 by 3. Let me write the values here again. Alpha plus beta 2, alpha beta 4 by 3. Now we're putting the values of alpha plus beta the whole square here. So alpha plus beta we said is 2, so this is 2 square minus 2 into alpha beta 4 by 3 over, this is alpha beta here, and that is 4 by 3 plus this is 4 over 4 by 3 plus 4. This cancels out. So the next step, we have 2 square is 4 minus this is 8 by 3 over 4 by 3 plus 4. This will be into 3 by 4 plus 4. So this will cancel out. Here you'll get 3, here you'll get 4. Now here if you take the LCM of the numerator, you'll get 4 by 3, here also 4 by 3. So this expression works out as 1. So next we'll have, let's go over it again. This is what we have. Now look in, I'm going to work the numerator out. In the numerator I'm going to find LCM, and LCM is 3. So this will be 12 minus 8 divided by 4 by 3. And this is plus 3 plus 4. Now again for the numerator, I have 4 by 3 divided by 4 by 3 plus 3 plus 4. And this 4 by 3 I cancel 1 plus 3 plus 4. Answer 8.